Introducing Geogemma barossi. Oh, hi, what an introduction. So dark down here. Anyways, my name is Geogemma barossi. You can call me Gemma for short, but please don't confuse me with my direct relatives, G. indica or G. pacifica. I don't know much about them. We never interact. Actually, I don't really interact with any other living organism now that I think about it. Never call me strain 121. I feel like I sound like a disease, and I actually never cause any to humans. As a matter of fact, my first encounter with a human was in 2003. I was found in this deep sea hydrothermal vent along the Endeavour segment of the Juan de Fuca Ridge in the Northeast Pacific Ocean, 200 miles off Puget Sound in Washington State. The reason for all the black smoke in this vent is because magma heats up seawater that gets into little cracks along tectonic plates. This chemical reaction causes mineral deposits. So this black smoke is actually iron sulfide. As you can see, I'm coccoid in shape and I have several lophotrichus-like flagella. Like most archaea, I keep it simple with a cytoplasmic membrane, periplastic space, and a single outer surface layer. My lineage goes back a long way. We'll go over the boring details first. Let's see, my domain is Archaea, my phylum is Archaeota, class is Thermoprotea, order is Desulphurococcolese, family is Pyrodictiae, finally genus is Geogemma, and my species is barossi. A fun theory I've heard since my discovery is that scientists were able to compare the sequences of the 16 sRNA among prokaryotes who exhibit the most primitive characteristics. They confirmed they are all hyperthermophiles like me, which made them hypothesize that perhaps life first occurred in deep sea hydrothermal conditions, especially considering way back then volcanic and hydrothermal activity was more common. I believe this. I won't let it get to my head though. I'm so smart. So yeah, it sounds like I'm kind of a big deal. Apparently, I hold the record for growth at the highest temperature for any living organism. Thank you, thank you. I grow the fastest at 103 Celsius, but can handle 121 Celsius. If the temp reaches 130, I'm still alive. I just stop reproducing until it cools down a bit. But I heard that someone is trying to steal that title, Methanopyrus candelier, just because they can grow at 122 degrees Celsius. I don't even think they deserve that title at all. Their optimal growth temp is 98 Celsius, which is so much lower than mine. Okay, back to talking about me. It's difficult to replicate my metabolism in a lab since I am an obligate chemolithoautotroph who cannot use oxygen. CO2 is my carbon source and iron is an inorganic compound that I use as my final electron acceptor. I reduce ferric iron to ferrous iron and magnetite is a byproduct, which is obviously why I live near these vents. The process of reducing iron oxide through respiration is actually a really important role in the biogeochemical cycling of iron. It influences the solubility and mobility of iron in various ecosystems. You see, iron exists in mainly two different states. Ferric iron in an oxidized state is difficult to dissolve at ambient pH, but ferrous iron in the reduced state is easily soluble. I'm not the only one who enjoys iron. Its reduced ferrous state is actually a vital micronutrient for phytoplankton. Phytoplankton also absorb a lot of carbon dioxide through photosynthesis, essentially regulating the ocean's carbon cycle and reducing atmospheric carbon.
Accepting files.
Oh no, it's happening! Everyone, stay calm. No need to be alarmed. It's just binary fission.
16%.
So, I've concluded that not only do I manage to maintain the marine iron cycle, but also influence the carbon cycle on the entire planet. Oh, and my great ancestors might have been the first living organisms on the planet. Wow, thanks for coming down. Bye.